Hello everyone, and welcome back to part 2 of lesson 6.6, Properties and Attributes of Kites and Trapezoids. In this video, we're focusing on trapezoids. So let's review what a trapezoid is first, and look at some basic terms having to do with trapezoids. Okay, the first thing is our definition. It's a quadrilateral with exactly one pair of parallel sides. Now remember, if there are two pairs, that turns it into a parallelogram. So we only have one pair of parallel sides. Okay, so that's going to be this blue line right here and this blue line down here. And notice that the two red lines that make up the other two sides, they're not parallel. Okay, and we have special terms for the different parts of a trapezoid. So the first is the base, and those bases are the blue lines, the ones that are parallel. Those are the bases. Then we have legs. The legs are the two sides that aren't parallel. So that's these red sides over here. They're legs. And last, we have base angles. Okay, so they're the two angles that are connected by a base. Okay, so that would be angle D and angle A in my picture. Those are base angles with each other. And then there are another pair of base angles. B and C would be a pair of base angles. Please note that I can't list B and A as a base angle pair because they're not connected by a base. Okay, so that's generally what's true about trapezoids. But there's actually a special type of trapezoid known as an isosceles trapezoid. So let's take a look at the facts about that. Okay, so an isosceles trapezoid is a trapezoid that has congruent legs. That means that the two sides that aren't parallel, so that's this one here and this one here, are going to be congruent. So they're not parallel, but they are congruent. That means they have the same length. Now, in an isosceles trapezoid, there are three special facts that are true. Okay, the first thing is that each pair of base angles is congruent. So that means that the two angles that are connected by one of those parallel sides are going to be congruent. So that's this angle here, and that's this angle here. And this kind of reminds me a little bit of having the isosceles triangles, where we took the equal signs on the sides and we went across from them and we said, okay, this angle is equal. And then we went to this congruent symbol and we went across from it and we said this angle is equal. Okay, so that's the same thing that's going on here. These two base angles at the bottom are equal. And then the ones at the top are also equal to each other. Now notice, this is definitely an obtuse angle up here. And this is definitely an acute angle. That's what I was saying earlier. The base angles are connected by a base. And those are the base angle pairs you're looking at, not the ones that are connected by one of the legs. Okay, so let's take a look at the next property. Now this is to help us to identify an isosceles trapezoid. If we have a trapezoid and we know that one pair of base angles is congruent, then we can say that it is isosceles. So looking at this trapezoid over here, if I knew that angle D and angle A were congruent, then I could say that it is isosceles. Okay, so that's how you can identify an isosceles trapezoid. Now finally, the last property of an isosceles trapezoid is that the diagonals are congruent. Now remember, diagonals connect non-consecutive sides. So that would be the segment that connects this angle over to this angle. And that segment's going to be congruent to the segment that connects this angle over to this angle here. Okay, so those two diagonals are going to be congruent. So let's take a look at an example question. Okay, so here's example 3. In part A of example 3, they want you to use the given trapezoid, which is right here, to find the measurement of angle Y, which is this angle right here. So take a look at the properties we have for our trapezoids and see if you can figure it out. Pause this video and then come back to see my answer. Okay, so I used a few of the properties of trapezoids. The first thing I used is that WZ is parallel to xy. Now I can use any of the properties of parallel lines that I want. So notice they're parallel lines and they're connected by a transversal. Okay, so then what that means for me is that angle W, which is 117 degrees, is same side interior with angle X up here. And I know that same side interior angles are supplementary. So what I did is I said that angle X plus angle W is 180. I put in the measurement for angle W and I solved for angle X. So angle X is 63 degrees. Now, because I also know that the two legs are congruent, that means X and Y are congruent. So angle Y is also 63 degrees. So I think we need another example about trapezoids. So here it is. So part B of example 3 wants us to find the length of PS. And PS is right here. Okay, so what we're given is that the length of RT is 24.1. They've given us that QP is 9.6. So pause this video and see if you can figure out what these two facts have to do with the length of PS, and see if you can actually find its length. Then come back here and I'll show you the answer. Okay, so what I figured out is that RT is a diagonal, and that means that it's going to be equal to the length of SQ. So both of those diagonals are 24.1. So I also know that the length of SQ is going to be the part plus the part. So it's QP plus PS. Okay, so QP plus PS is going to be that 24.1. So I just put in the measurement for QP, and then I subtracted to find out the length of PS, and PS is 14.5. So now you have another check it out question coming up next. So here it is. So check it out question number 3 can be found on page 430 of your textbook. Please add this to the Google Doc you started in video 1. Okay, so they gave you two trapezoids and they want you to find some missing measurements. So pause this video, see if you can find those measurements, and then I'll meet you back here for another example. Okay, welcome back. Example 4A looks like this. They've given you a trapezoid that they want you to make an isosceles trapezoid. So think about what needs to be true about these two angle measurements in order for it to be isosceles. See if you can write some sort of math statement and figure out what y needs to be. So pause the video and then come right back here where I'll show you how to find the answer. Okay, so what I decided to help me solve this is that if EFGH is isosceles, then angle E and angle H have to be congruent because they're the base angles of my isosceles trapezoid. So what I did is I set up an equation. 2y squared minus 25 equals y squared plus 24. Okay, now to solve this equation, I subtracted y squared on both sides. Then I added 25 to both sides. And then I did the square root of 49. Now when you do that square root, you need the plus or minus sign on it because you introduced the square root. And notice that the negative 7 would still work in here. Normally they don't because you can't have negative lengths, but in this case it does still work because in both of these expressions, they're squaring the y. So it could be either positive or negative 7. So let's do another example to make sure you have that. So in example 4b, they've told us that JL is 5z plus 3. They've told us that KM is 9z minus 12. And they want you to figure out what z needs to be to turn this into an isosceles trapezoid. So pause this video, look at your facts, and see if you can figure out what z needs to be. Okay, so here it is. I decided that if this was going to be an isosceles trapezoid, then JL and KM must be congruent. Okay, because remember, in an isosceles trapezoid, the diagonals are congruent. So I set up this equation, I subtracted 5z from both sides to get 4z right here. Then I added 12, and then I divided by 4. So z must be 3.75. Okay, so it's time for another check it out question. On page 430 of your book, there's check it out question number 4. It looks like this, and you're going to be following the same things that we did in our example. So pause this video, do your check it out question on that Google Doc, and then come right back here for our last section. Okay, so our last thing to talk about is the mid-segments of a trapezoid. So think back to when we were talking about triangles and their mid-segments, and see if you can remember what a mid-segment does and how it might be applied to a trapezoid. Okay, so hopefully you remembered that a mid-segment is something that connects midpoints. So notice the picture over here. The mid-segment for a trapezoid connects the midpoint of a leg to the midpoint of the other leg. Now notice, although this leg is cut in half, it's the midpoint, these two halves are not actually equal to the two halves over here. Okay, so that's the mid-segment. And in trapezoids, mid-segments have some very special properties. Okay, and they're very similar to the properties for triangles. So this mid-segment is parallel to both bases. So all three of these lines are parallel. Okay, and if I take this base plus this base and I add them together and then I divide by 2, it will get me the mid-segment length. Okay, and that's basically an average. So it's the average of the base lengths. But there is a really cool property. Because the mid-segment is parallel, it's basically like equally spaced. So if you can find out the distance from this to the mid-segment, then that distance is going to be the same from this mid-segment to here. So if this base loses like 5 inches to get the length of the mid-segment, then if I take the mid-segment length and I subtract 5 more inches, it's going to get me this base length. Okay, and the really cool thing is that it works the other way too. If this is 10 inches and I have to add 5 more inches to get this length, then I add 5 more inches and that'll get me this base. So let's take a look at an example. Okay, so in example 5, they want you to find the length of ST, and ST is this base of the trapezoid. So see if you can look back at those properties and figure out how to find the length of ST, and then meet me right back here. Okay, so there are actually 2 options to solving this. The first one is to use the triangle mid-segment theorem, which says that the mid-segment, MN, is equal to the 2 bases, ST and RU, added together, and then divided by 2. So what I did is I took my measurements and put them in. I multiplied by 2 on both sides to get rid of this 1/2, and then I subtracted 38. So ST is 24. Now, my other option is to use the properties of mid-segments that I was discussing on the previous picture. Okay, so that property says that these are all evenly spaced. So this 38 went down by 7 to get 31. So if I subtract 1 more 7, it's going to get me the length of ST. Now, that got me 24, and that is the answer. If they started out by giving you the shorter length, and then you'd have to add to get to this one, then you add again to get to the longer length. Okay, so you have one to try next. Okay, so you're going to complete the last check it out question in our lesson. It's found on page 431. So they've given you this picture. See if you can find the length of EH. Then submit your Google Doc on Google Classroom. Have a great day.